All right, today I'm gonna talk about AC maintenance. Woo! It's the most fun thing in the world. That's sarcastic if you didn't know. Actually, I don't mind doing it. I really don't mind doing AC maintenance and AC just PMs and stuff like that. I want to talk about though, like the importance of it, because I feel like a lot of times people don't actually maintain their air conditioning systems until something fails, and they're like, "Oh God, I have no AC. It's 95 degrees out. It's humid, and my cat's dying. I need help." I suppose I should probably get to work. So yeah, air conditioning maintenance. What's involved with that is what I'm going to kind of get into today. I don't think many people know. When people come to their house, they're like, "Hey, here to service your air conditioner." I don't think they really know what that entails, what's included with that. They kind of just go, "All right, take care of it," and hope that it works after they're done. So I want to kind of talk about at least what I do as far as AC preventative maintenance goes. I just left the one that you're going to see clips in between this video of kind of what I do. There's a couple things I wasn't able to get on camera, just either due to the location or stuff not being available to me, that kind of thing. But overall, I got a pretty decent idea of, you'll get a pretty decent idea of what I do. First off, I want to start by saying, how often should you maintain your air conditioner? I believe that if your company that you use, offers a service plan or something, that's what our company does. We offer yearly maintenance agreements that include a yearly maintenance on your system, as well as discounts or whatever for repair work, stuff like that. So in that case, if your company uses a yearly contract or a yearly maintenance agreement, take advantage of that and just get it done yearly. It doesn't make any sense not to. You're already paying for it, so just do it. If you are more of a pay by job kind of person, where you have someone that comes, does the AC, and you pay for it, it's not detrimental, if you don't do it yearly. Obviously, you have your own responsibilities as a homeowner, such as checking your air filter. I go to so many calls where, oh, I have no airflow. There's something wrong with the air conditioner. I have no airflow. And, 75% of the time, it's a plugged air filter, because people are like, I didn't even know that was in the system. No one told me that. And I'm like, okay, well, that's bad. Pretty much, that's the biggest homeowner responsibility. Just change your air filter. Every 3 months is the recommended procedure. So every 3 months, pop a new one in there, or at least check it. If you don't have one on hand and you pull it out, it's not dirty, just at least check it, be on top of it, because number one, your airflow is crucial to air conditioning systems. Okay, so if you don't have sufficient airflow across that evaporator coil, you're going to end up freezing the coil. You're going to have no airflow through the vents, and you're going to go, what the hell's going on? I have water all over the place. I have water in my ceiling. I have water in my basement floor, and it's going to freeze up. That's because you have no airflow. So you just have all that refrigerant pumping into the evaporator coil, and there's no air. So it's going to freeze up. So that's why it's very important for you as a homeowner to take care of your air filter, because that's going to save a lot of headaches, a lot of service calls, a lot of technicians at 1 o'clock in the morning coming out and going, air filter, this is your responsibility. Other than that, yeah, I say get it checked once a year if you have a service agreement. If not, every couple of years is not going to be, a big deal. Just make sure you stay on top of your air filter. So basically, the first thing I do, I'm going to get into my step-by-step procedure as to what I do in air conditioning maintenance. The first thing that I do when I get to the home is I greet the customer, tell them, hey, I'm here for the air conditioning maintenance. This is what I'm going to do. It should take me about X, Y, and Z. This is the time frame. It should be done, whatever, blah, blah, blah. Just make conversation with the customer. Then I usually just do a visual inspection of everything. I walk to the outdoor condensing unit, look at the condition of the coils, see how old the system is, see if it's even running. If you have pets, dogs that like to pee on the condenser, you might notice you're going to have coil fins that are rotting, and because the acidity of the urine will eat through the coils, and we'll start having what I call skeleton coils, where it looks like rib cages around, and obviously that's an indication that something's wrong. So overall, like I said, just do an overall inspection of the condenser, see if the coil's dirty, if it's plugged up, the line set, see if there's rot in the line set, or if your insulation is falling off of the lines, just stuff like that. Thermostat wire, check and see if there's any breaks in the thermostat wire, any mice chewed through it, stuff like that. Just simple stuff that you can see on the outside without even taking anything apart. The next step, and same thing goes with the indoor unit. Go downstairs, whether it's a furnace in the basement, a warm air furnace that has a coil, or an air handler in the basement, or air handler in the attic. Attics suck. But just do an overall kind of inspection of it, just so you can catch any obvious issues off the bat and have that conversation with the homeowner and say, listen, I'm already seeing stuff. What do you want to do about it? If there's no issues with your inspection, first thing I do is I go to the service disconnect and I pull the disconnect plug to kill power to the unit. Just because if you're working on an air conditioning system and you have power to it, all you need is just to cut your hand off with a fan or electrocute yourself. So pull power to it. That's the first thing you do. No exceptions. If you cannot kill power to the system for whatever reason, I won't work on it, because that's now a hazard to me. That's dangerous. I'm not working on live voltage that can injure me at any time. Make sure you can kill power to that system. After you kill power to the system, what I do is I normally pull the electrical panel off to just do a visual inspection of the indoor, or a visual inspection of the electrical outside. See if there's any mice, any nests that are inside. I usually remove. Obviously, I don't know why I would just leave a nest in there. So to remove any nests, check the wires, especially if there is a nest in there. Look over all the wires, all the coating on the wires. Make sure there's no chewed wires. That is so common. It's unbelievable. Thermostat wires, the line voltage wires coming in, the fan wires, the compressor wire, the capacitor, stuff like that. Just check all the wires. Make sure there's no bare exposed copper wire, because you're gonna have shorts, stuff like that. Or if there's breaks in the wire, it's just not gonna operate at all. So that's the first thing I do when I open up that panel. After that, the next step that I do is check the contactor, where check the contactor, make sure there's no bugs or anything caught in the contactor where it's not going to make a complete connection. Also check see if it's real burnt. And take your meter leads, set it to ohms, and check across the 24-volt coil on the sides. I don't have a clip of me doing that, but take your meter leads, one on each side, and you should have around 15 ohms. If it's real low, where it's like at 1, or if it's real high, replace the contactor. That means that contactor is failing and no good. So you should have relative in the range of 15. I'd say, anywhere from 10 to 20 is acceptable. After that, I usually pull my capacitor. If you guys don't know, capacitor is probably the number one issue with air conditioning. If a system fails where the indoor unit is running and you have air blowing, but the outdoor unit isn't doing anything, the number one most common issue is that capacitor. Okay, so the way I describe capacitors to customers, which may not actually be accurate, but it's just the way I describe it to make them understand, is I describe the capacitor as a battery, basically just a battery that stores voltage. So when your compressor and your condenser fan motor kick on, it needs that power to start it. That's how I describe it to customers. Most of the time, they kind of understand what I'm saying. And all those capacitors are rated for a specific number of microfarads. So and there's usually two numbers. If it's a dual capacitor, it could be like a 40/5 or a 35/5 or a 60/7.5. One of those numbers relates to your compressor and one relates to the fan. And always want to check what they're reading when you get there. That way you can catch it if it's starting to fail or it's starting to weaken. You can catch it and save a service call. And that's what happened with this one actually. Is it's a 40/5 microfarad capacitor. So you have 40 on the hermetic side and you have 5 on the fan side. I was getting 38 on the hermetic side and I was getting like 1.8 to 2 on the fan. That's basically failing. I don't know how the thing was working. So talk to the homeowner, say, hey, you know, your capacitor's weak, is very, very weak. It's probably not going to work another week. And I think we should get this swapped out. That way we can avoid having to come out and charge a service call fee. We can just get it done over here and waive that, and therefore save some money, and therefore you don't got to worry about the big fail on you. So, all right, perfect. Yep, do it. Went out, grabbed a Turbo 200 universal capacitor, wired it up for a 40/5, and that's it. You're ready to go. So the electrical components are very important. Those are like where most of the issues are with a AC system. So always check them over, check your readings, stuff like that. Just try to catch stuff before it fails. That's the whole point of preventative maintenance, is to prevent issues. Now, another very important thing that I wasn't able to catch on camera is cleaning the coil. The reason why I wasn't able to catch this on camera is just because I did not have any water source at this house for some reason. They, like, at least nearby, there was nothing close where I could hook up a hose and run it to the condenser. But always clean your coils. I always do. Trust me. What I do, some people will spray it from the outside around the condenser. I don't agree with that. I think it's not the right way to do it. What I do is I unwire the fan and pull the whole fan motor assembly off, and therefore you can get a hose in your soap, your coil cleaner, or whatever. You can spray it inside and push all the debris and dirt out. And it's not a hard process. Usually most condenser fan motors are 3 wires, and just take them off, pull the screws out, pull the whole top off, and now you have wide open access. While you're down there, I usually pull, you know, leaves or dirt or mulch or whatever just from the bottom of it, just because it's not going to really affect much for the performance, but it just looks nice, and that's why I do it. So yeah, cleaning the coil is very important. If you don't clean the coil, you're not going to have sufficient airflow across, you know, in your compressor and everything. You're not going to have air coming in, you know what I mean? And you're gonna start having high head pressure. It's just, the system's not gonna be running well. You're gonna be running at higher amps, the compressor's gonna be working harder. It's just gonna be not good. So that's why it's very important. You know, it might still work, you might still have cooling, but it's not gonna be performing as efficiently as it should be. And just washing down the coil is a very simple thing to do, so why not? So next on the list, after you're done with the outdoor unit, we're going to make our way inside to the, like I said, if it's a warm air furnace, the one I was just at was a warm air furnace, or it could also be an air handler or an air handler in the attic. Like I said, attics are the worst, but part of the job. So first thing I do with the indoor unit, like I said, prior to everything, we always do a visual inspection, just kind of go through everything, make sure everything looks fine from the naked eye. And then we'll start digging into a little more. What you do inside kind of varies based on what is accessible and what isn't. That's just me being honest. If you have like a warm air furnace with a case coil, where you know you can easily take the screws out and get to the coil, then I always pull the doors off, look at the coil, the top and the bottom. You know, pull the plates off the coil, check it out, because even though the top might be clean, the actual underneath the coil that you can't see from outside might be plugged. You know, and that can also cause them to freeze up, stuff like that, because again, you're losing that airflow. So yeah, if you can do that, then do it. Sometimes it's all, you know, just encased in ductwork, and you can't really get to it without cutting all the ductwork open. In those instances, I typically don't check the coil, just because it's such a hassle. It takes a lot longer. Again, I mean, this is preventative maintenance. It's not necessarily a service call. If it was a service call and there was an issue with airflow or freezing or, you know, that kind of thing, then I'd probably look into a little more. But since it's such a hassle in PM, I mean, it all depends on the situation. Another important thing, condensate drain. Every unit has a condensate drain. So inside of your air conditioning unit, there is a condensate pan. A lot of times, attic units, they'll have a primary pan inside the air handler underneath the evaporator coil, and then there'll be a secondary pan underneath the entire air handler, where if that primary pan fails, or there's a blockage or something, it'll overflow into the secondary pan as a way just to keep the water from overflowing through the ceiling. So when condensation occurs and you have all that water that builds up on the coil and runs off, it'll run into this primary pan, and there's usually a PVC drain that is connected to the pan. And move over here, move out of my way. There's a PVC drain that is connected to that primary pan, which will run, if it's in a basement, it'll run to a condensate pump most likely. Or if it's in an attic, it'll run outside somewhere, probably just outside of the house and down is the most common setup. Always make sure we clear those drains because if you don't, you can have a blockage, like I said before, and especially in an attic, that can be a big mess because, like I said, if it overflows, if that pan cracks or there's a blockage in the drain, you'll have all that water builds up and starts overflowing, and it goes onto the ceiling. So you'll start having all the bubbling in the ceiling, and eventually, that thing could collapse. And I've seen ceilings fall. I've seen severe water damage just from people not maintaining their system, and that's what happens. A lot of times, to prevent that, though, if a unit has a secondary pan, they do have, a lot of times they'll have a safety switch or a sensor where if water goes in the secondary pan and that sensor detects water, it'll kill the power to the system to prevent it keep producing condensation and keep on flooding it. It's either a sensor where it touches the water, or it could be a float switch where if the water goes up high enough, it'll push the lever up and then kill the power. Those are usually the two styles that you run into. So yeah, clear drains. I use a Milwaukee M12 vacuum. It's just super lightweight, convenient, bring it in and out as needed. And it always gets the job done, and no blockages. So there you go, you don't got to worry about it. Same thing with the basement unit. Hook it up, clear it, vacuum the drain line out, because then if not, you'll have water that falls down the side of the furnace and gets all over the floor. We don't want water anywhere but the drain and the pan. That's it. After that, very important, like I said before, just check the air filter, pull it out. They say every 3 months. Sometimes don't need, sometimes you can get away with every 6 months. Sometimes you can even get away with once a year, but every 3 months is the recommended procedure. And at least check it, you know what I mean? When you pull it out, if you can't see light through it, it's plugged 100%. Like, you cannot have that filter in there because it will just freeze up the system. The same goes for the heating too. Like on a warm air furnace, if your filter is plugged solid, you're going to be going off on high limit and stuff because you don't have that airflow to cool the system down a little bit. So when you're running it for heat, that heat exchanger is getting really, really, really hot, and there's no airflow to keep it cooled down enough. So it'll go off on high limit, and it's just a whole nother mess there. And then usually the last thing I do will just be a delta T reading. Delta T is a measurement between your supply and your return temperatures. It's the difference between those two temperatures. So for instance, if you have 70-degree return air and you have 50-degree supply air, you have a 20-degree delta T. We usually look for about an 18, at least an 18-degree delta T. Like from like 18 to 23 in that range we usually look for. That's indicative of a healthy system. And the way I do that is I have my field piece meter and I have a K-type probe that does temperature. So I'll put 2 holes, one in this return duct, one in the supply duct, and I will do separate readings. So I'll take a return temperature reading and then let it stabilize, get to where the actual temperature is. And then I'll switch it over to the supply duct and get my reading there. Same thing, let it stabilize and see what it is. In this case, we had about an 18-degree delta T. With the system not running very long, so if I let it run a little bit longer, probably could have gone into a 20-degree. That's perfect. There's nothing really to worry about there. So, and I've also seen people use like thermometers, like handheld infrared thermometers or whatever, to basically shoot point at vents. That works. It'll get the job done, but I've always been, in favor of going directly across the coil. That's where you get the most accurate, reading. So yes, if you have a handheld thermometer like this, you know, you go and you point it, you can get a delta T reading, but I just prefer to go from oil. That's the more proper way to do it. So yeah, I mean, that's generally it for AC stuff. Another thing I forgot to mention before, when you pull the fan off the top of the condenser, I always just check and make sure the fan blades and everything are all intact. They're not rotted out. They're not bent. I had one actually recently where we had a storm here and a branch fell on top of the cover for an American Standard, that top grate. It was all dented in. Didn't damage anything else, just the top cover. So in that case, you know, pull it off, and we do an inspection of that too. So just another side note I forgot to make earlier is just kind of check everything while you're there. Just make sure there's no issues. Make sure the system's running as designed, and that's it. And you'll be good for the year. Yeah, that's basically it. I mean, it's preventative maintenance. It's nothing too crazy. It's nothing too in depth. Just bottom line is make sure the homeowner is you know, the system's working. Make sure that they're staying cool in the summer. Now you can also dig into, you know, amp draws and stuff like that. So especially on older systems, sometimes what I'll do, if they're really, really old, I'll take my meter and I'll put my amp clamp and I'll check the amp draw off the compressor legs. And you know, on a 60 amp breaker, if you're running at 40, 50 amps, then you know, okay, well, this thing's on its way out. You know, especially if it's an older R22 system, this thing's on its way out. It's well past its life expectancy and it's struggling to kind of run. It's working really, really hard. You're paying a lot more electricity, and you know, we should start looking towards replacement options, that kind of thing. So you kind of can tweak your procedures, tweak your routine based on the, you know, the system you're running into. Obviously, if it's a brand new system and it's working perfectly fine, you're not going to really need to get your amp clamp out and start reading amp draws and everything, unless you want to, just because it just makes it feel good. Go for it. It's not going to hurt anything. If anything, it's good. But generally, that's basically it. I would have liked to get more clips to kind of show you different things, but like I said, this one was kind of like a tough one to kind of get clips of. But I just wanted to kind of go through that with you. At least, you know, it is AC season. It's getting hot, so I figured it was a good time to talk about AC maintenance and kind of, if you're a homeowner, kind of give you an idea of what we do, or at least what I do. And if you're a technician, you know, kind of compare your routine with mine, and just for fun. And that's basically it. So I appreciate you guys tuning in for another video. I know I'm very inconsistent with stuff I really want to try to get on a weekly schedule, but it's just busy, man. So it's like when I get home, I want to sit on the couch and not do anything. So, but I am going to try, and hopefully you guys enjoyed. So if you did, leave me a like on this video. And if you're not subscribed, please do. That helps me. And that's it. See you later.